lesson, we're going to look at the Gibbs free energy application to some processes that we're familiar with and see how it can help us figure out how to use it, how it is that it's going to tell us about spontaneity. Okay, so the homework problem was to write in claim and justification form whether or not water or freezing of water is spontaneous and if necessary explain the conditions. Okay, that's a pretty simple reaction here we're talking about. It's a physical reaction, but it still applies to the Gibbs free energy equation. And you were supposed to explain it in terms of the Gibbs free energy equation. The Gibbs free energy equation, in the Gibbs free energy equation, you've got a delta G term, you've got a delta H term, you've got a negative temperature term times a delta S term. Temperature is always positive, but these other two terms can be negative or positive, and that's going to govern whether delta G is going to be negative or positive. If delta G is negative, you've got a spontaneous reaction. So the question was about whether the reaction will happen or not, whether it's spontaneous or not, and if so, under what conditions. So what we have here is water in liquid form that's becoming water in solid form. Okay, pretty simple, right? And it kind of goes back to Unit 7 when we're talking about structural particles for the first time. Okay? Question is delta G going to be negative or positive, and is delta S going to be negative or positive? That's going to tell us everything we need to know. So, looking at this reaction, liquid water becoming solid water, is delta H going to be negative or positive? What? Negative. Why do you think it's going to be negative? Got to take heat out of the water. The only way to freeze the water is if you take heat out of it. So if you're taking the heat out, delta H, which is a measure of the change in heat energy or energy of all kinds in the system, and the system is the water. So the delta H is going to become negative because we're taking energy out. That homework? Mm-hmm. Did you exchange paper already? Well, you need to give it to me, please. All right. T is always positive because we're using the absolute temperature scale, the Kelvin scale, okay? What about delta S? If you're going from liquid water to solid water, what about delta S? Delta S, or S, is the symbol we have for entropy, which means disorder, okay? So is this system becoming more or less disordered? Less disordered, because we're taking this liquid where the molecules are moving around each other. They're touching, but they're moving around each other, and we're locking them in place. And even though they're wiggling and twisting, they're locked in place. That's more ordered than liquid water, okay? And so we're reducing the amount of disorder. We're ordering it more, so we're reducing the amount of disorder. That's a negative term. All right, let's just make sure we write these out. We're losing energy. That's why delta H is negative. Loses energy. And we're increasing order, which is the same thing as decreasing disorder, kind of a double negative thing. I'm sure the English teachers hate me for that. And the term for disorder, the symbol for disorder is entropy, or the word is entropy. We use the symbol S. Okay? All right, now, when, if ever, will delta G ever be negative? When temperature's low enough. Okay? That's good. So, if the temperature's low enough, temperature, not thermometer temperature or whatever it is, whatever it was, I started it right, is low enough, delta G will be negative, and the reaction will be spontaneous. Now, let's write that out in claim and justification form. Okay, so we're real clear about what it is we're supposed to do. Your answer should be in claim and justification form. So I'm going to write out specifically claim and justification. Now, it's not required that you write out the word claim and then write the claim, but just that you state this. That makes sense? I'm simply going to label it as claim. All right? So the claim that we have here is that freezing water, or this reaction, however you want to state it, freezing water is spontaneous if the temperature is low enough. Okay? That's the claim. It's not all the time spontaneous. It's not never spontaneous. There's another double negative again. Sorry, English teachers. It's spontaneous, but only if the temperature is low enough. Now, you can state it in whatever form you want to, but you got to kind of say the same thing. Does that make sense? You can say it in a little bit different words. I want you to use your own words. Okay, that's the idea. Not my words, your words, but kind of say the same thing. Not kind of, say the same thing. Okay? Now, if you did that, then you've earned 10 points. Okay? Now we're going to get to the justification. The claim is simple, straightforward, right to the point. Okay? Now the justification. Again, you don't have to write out the word justification. I'm just labeling it here so you know what I'm talking about. Okay? And there's like 4 parts to this justification because we've got that many parts to this to reach the point where we're saying it's spontaneous. Okay? The first part I want to deal with is whether delta H is negative. Okay? So I'm going to say when water freezes. Now these are my words. You can use your own words, but you got to say the same thing, essentially the same thing in your own words. When water freezes, it does so because energy leaves the system, which is the water, or between the water molecules. Okay, you could say the water instead of the system. And so, delta H is negative. And that's what we set up here. Okay, and that statement right there, that's 10 points for you. Okay, and then we're going to deal with what's happening with delta S. Okay, and we're going to say when water freezes. Move it up a little bit so you can see it. When water freezes, the molecules stop moving around. Are moving around each other. Because they're still wiggling, they're still twisting, but they're not moving around each other, relatively to each other, okay? You could say they lock into place, okay? And then this is a more organized state. Or you could say, I should have said ized, organized. This is more organized. You could say it's more ordered. You could say it's less disordered, okay? So delta S is negative. Okay, and that's worth 10 points. All right? And then we're going to say under these conditions, this is when delta G can be negative, okay? So under these conditions, no, you got to say that this is the case, when this happens, okay? Explain it in your own words. The question was, do you have to say it, use those terms? No. Okay? Under these conditions, then delta G is negative. And you could say so long as, or you could say if and only if. So I'm going to say so long as the temperature is low enough. And that's worth 10 points. And we're almost there because now we got to write the statement that connects a negative delta G to spontaneity, okay? So if delta G is negative, The reaction is spontaneous. So, freezing water is spontaneous if the temperature is low enough. And so that's worth 10 points. So we've got a total of 50 points here. Okay. What now? What? I didn't hear what you said. Oh, well, it is. Any questions? Does that make sense? I'm looking for just clear, straightforward, step-by-step explanations. Scientists love that stuff. Okay? You know, English teachers might not, but scientists love that stuff, and that's what I want you to try to learn to do. We're near the end of the semester. I'm trying to, put your nose to the grindstone here a little bit and make sure you can actually write something clear and convincing. 1, 2, 3, 4, convince me of it. Got it? And this is a really good chance for you to do that.